Welcome to the topic number 4, the sustainable engineering. In this topic we will discuss the questions like what is the role of engineers in the sustainable development and how should the activities of engineers change under the influence of sustainable development agenda. So there is a general consensus that traditional engineering solutions and ways of thinking will not produce sustainable solutions. Rather, such solutions will come from innovation, focuses on building on social, cultural, and environmental strengths, and using lateral or critical thinking. The given diagram shows a general framework for sustainable engineering principles as compared with traditional engineering that are partially adopted from the work called Sustainable Development in Engineering, as well as the Green Engineering Principles established in 2003. Here you can see the key differences between traditional and sustainable approaches to engineering, like for example that traditional engineering considers the object or process, while sustainable engineering will consider the whole system in which the process or object will be used. Now, let us take a look at different approaches to sustainability in engineering. Sustainability problems are widely recognized as complex problems. Many engineering and science scholars provide quite conflicting views that range from conservative to proactive with regard to the need to reform in science, engineering, technology research, and education. A more conservative view suggests that culture guiding scientific research doesn't need to change fundamentally in order to advance sustainability. From this perspective, science can meet the challenges of sustainability by inventing sustainable technologies that drive innovation. This outlook also suggests that any aspect of complexity unaddressed through innovation fall outside the bounds of normal science. Some scholars characterize this point of view as business as usual and the systems engineering. The business as usual is the most common approach to sustainability. The solution is to simply repackage the normal incremental practice of research and development as pertaining to making the world in general a better place, and as a result relevant to sustainability. However, the business as usual approach typically ignores environmental and social issues altogether, especially those issues that may only emerge at some scales, and may even ignore the relevant economic considerations. At the same time, the systems engineering is a more modern approach to sustainability. In general, there are two perspectives within this domain, both of which seek improvement at the scale of integrated systems rather than piecemeal component optimization. The first outlook is engineering within sustainability constraints, in which the engineering systems are typically optimized for more traditional objectives like cost minimization. The second perspective goes further than the first one by expanding the design objectives themselves to incorporate the triple bottom line of sustainability: the economy, environment, and society. Nevertheless, engineering optimization within ecological constraints, as well as the triple bottom line approaches, usually still ignore the questions of scale and are therefore vulnerable for the criticism that the new technologies that make goods more efficiently and therefore cheaper will result into unsustainable growth in consumption. On the other hand, a more proactive view suggests that some scientific sectors require a radical reorientation in order to meet the challenges imposed by the sustainability problems. A sustainable engineering science represents a paradigm shift in the way that science approaches the problems of technology and complex systems. In this context, sustainable engineering science represents a post-industrial attempt to change both the perspective and the approach to science that created complex problems of nowadays, like waste or climate change. What else should we know about sustainable engineering? In 1997, the World Federation of Engineering Organization issued the following resolution. The organization encourages all engineers to become knowledgeable of sustainable development principles and be continuously trained about the current sustainable development technologies applicable to their work. As well, the key policies, principles, indicators, and guidelines for putting sustainability into engineering practice have been previously developed by the International Federation of Consulting Engineers. At the same time, the United Kingdom Royal Academy of Engineering, alongside the visiting professors, considered the engineering aspect of sustainable development in the context of many principles of sustainability and sustainable development that appeared in the literature. As a result, they identified a set of 12 guiding principles of engineering for sustainable development, which you can see on the screen. So the 12 principles of engineering for sustainable development include the following. Look beyond your own locality and the immediate future. Innovate and be creative. Seek a balanced solution. Seek engagement for all the stakeholders. Make sure you know the needs and wants. Plan and manage effectively. Give sustainability the benefit of any doubt. If polluters must pollute, then they must pay as well. Adopt a holistic, cradle-to-grave approach. Do things right, having decided on the right things to do. Beware cost reductions that masquerade as value engineering. And lastly, practice what you preach.